Good morning, Hacksters! Today I have a package from SparkFun, including some microbit edge connectors, and we're going to take a look at a bunch of different options that you have for connecting your microbit to other pieces of hardware that you're going to be designing, including open source options with KiCad and whatnot. We're going to try and do this fast and pretty, so let's go. I've got this box from SparkFun, which actually has a couple of other things in it, so it might take me a minute to find the... Fresh box. All right, we got packing stuff. We've got some giant buttons actually for an upcoming project. Look at these 10mm dome buttons. Oh, so satisfying. We'll come back to those in a while. All right, and we have a few different options for microbit connectors. So first up, there are these, are these regular straight ones? Oh no, these are for PCBs, it looks like. I don't quite remember exactly what I ordered, but we're going to focus on the ones that mount to breadboard. So this is actually one that you can get that you can design your own PCB to connect to it. And that's actually really exciting. I forgot that I got that. Wow. Okay, so you can order from SparkFun these ones that they have a footprint. You can connect to them with your PCB without having to design your entire own footprint, which is very exciting. Then the one that I was most excited about are these ones with the Qwiic edge connector. If you're not familiar with Qwiic, Qwiic, it is a new, it's actually not new anymore, but it's a type of connector from SparkFun that enables you to connect things together quickly and easily with these tiny little Qwiic cables. There's like 4 pins in there that they use to talk to other devices, and I'll show you a couple of those in a second, I think. You can get them with or without headers already soldered on. So I got a previous version of this that didn't have the Qwiic connectors, and I ended up soldering in... yeah, you can still get the version without the Qwiic connectors, in fact, but that comes without the headers soldered in, and so I soldered in some right-angled headers because I wanted to have a straight connector so I could plug the board directly in like a cartridge into some other project. And that did work. I decided to make it like this on a SparkFun breadboard so that it can sit on my desk. And this version comes with straight headers already soldered on, so you're going to be like the microbit is oriented up this way, and you're going to plug it back into something. And that's for actually the same project where I'm using the big buttons. Let's take a look at these closer up. Here is the one from before that is just a regular microbit breakout with no headers and originally soldered on and no Qwiic connector. So I put right angle headers into here so that I could stand it up on my desk and have it be a display for different types of projects. Like a Pomodoro, for example, for productivity. And then here's the one that I just ordered that has straight headers already soldered on, and it comes with these Qwiic connectors on either side. You can chain Qwiic connectors so that you can have them go in a daisy chain, but I think these are individual ones, so you have one over here and one coming out over there. You can control 2 different Qwiic devices. Very exciting. And then here's the third type, which just plugs directly into a PCB that you've designed. If you want to make your own microbit expansions, then you can totally do that. And actually, there's one more thing in here that is designed, if you want to know what an expansion would look like. There is this moto bit from SparkFun, which is designed for making robots. Now, I got this mostly as an experiment because the type of robot that I'm designing right now would ideally, this would be able to flex and be at a 90-degree angle from the rest of the motor controllers, or even vice versa, like flex it around. But it is rigid. I assume there's a bunch of little connections in here that you wouldn't want to disrupt. And so I would really love it, actually, if SparkFun came out with a version of this where it was had like a flexi connector in here, and then you could angle it a different way, because there's lots of different types of robots that people want to make. But it is really convenient. You've got these sensor breakouts, a servo breakout with PWM, power in, another Qwiic connector, and stop and run motors switch. So that's pretty cool. So a bunch of items, a bunch of different options for you if you are getting started connecting your microbit to other hardware. And this is interesting. Let's take a look at some of the documentation and the other stuff that you can find online, because some of this stuff is going to make a little bit more sense in a second. So here is the Qwiic microbit breakout that I just showed you, the newer one. And this one has headers soldered on. And you can find this board's sibling down here for the one without headers soldered on, if you want to put right angle headers in there and be able to connect it straight on to other things. Similarly, here's the old version without the Qwiic. Oh, wait, no, this is not the old version. Where's the old version? Well, you can still find the other one in the microbit section on SparkFun, but I'm not going to scroll through and find it right now. Both of them do still exist on there. Ah, here we go. SparkFun microbit breakout with headers or without headers. You do have to purchase your microbits separately. Oh, interesting. So if you click on the one with no Qwiic, it takes you straight to the one with Qwiic for no headers. Didn't notice that before. SparkFun has a microbit breakout board hookup guide, which makes it really easy for you to get started with this. They tell you what you need. You can just order all this stuff, get your microbit, learn about the Quick Connect system. They give you a hardware overview with some of the pinouts. This is a pretty good functional pinout that's very readable. We'll take a look at some of the microbit official documentation in a second, but they tell you what some of the different pins do. There's some really interesting stuff with LEDs going on here that we'll cover in a second as well. They've got the board outline. You can click on that. How to attach the headers, how to build an example circuit, and how to program it in Microsoft MakeCode. MakeCode is super cool because you can also switch it into JavaScript mode, which shows the same code, but in JavaScript, and you can switch it into Python as well. And then you can edit this code, and it'll update the visual drag and drop code editor to reflect that. So it's actually a really cool way, I think, that Microbit has made it possible for you to get started, in programming, doing drag and drop stuff, but then upgrade slowly to typing your code and sort of understand how those things work together. I think it's really cool. And then how to get it onto your board and how to use a quick sensor. I am totally going to be using that because I got like a quick LED stick as well. SparkFun, I just wanted to show you, also sells a bunch of other breakouts and kits for the microbit, including this little buggy that's super cute. And this uses one that we've covered before, the Kitronic Servo Kit board. So on the microbit official page, you've got these documentation pages. This is a really in-depth view at the edge connector and the microbit pinout. In case you're designing your own accessories, really good reference. So you've got all of this stuff. They link you to microbit.pinout.xyz. Pinout.xyz is actually a wonderful resource. This one is microbit specific, but there's also, they have pages for, Raspberry Pi breakouts and things like that. All kinds of different expansions and connections. If you want to see what the pinouts are, it's a beautiful graphical guide. And as you see here, you can click on the different pins and see what their deal is. So you're like, okay, on the, this diagram, it's a little bit overwhelming. It is cool they show you both V2 and V1 of the microbit, by the way. But then when you look at this, you can actually dive in and be like, okay, what does that mean? Tell me more about it. Very cool. And I looked at this specifically because I was curious about this pin that's reserved for accessibility. It turns out that they don't recommend you connecting things to it right now, even if you're designing your own accessibility devices, but it seems like it was intended to be a UART transmit pin that would stream accessibility data to an accessory, or perhaps to enable or disable an onboard accessibility mode over USB. It seems like that isn't quite implemented yet, but it's cool that they're thinking about that for the future. This is why I say that the SparkFun pinout information for this is very readable. That's quite readable. And then you come here and you're like, oh my gosh. And this is great. It's great information for if you really need to dive into what exactly is going on the board. And they do give you a key. So MB ring is like the microbit basic interface 5 rings. Mod is the pin number on the module bit. MCU is the actual pin name on the Nordic MCU chip. And so you'll see, for example, in the far left column, you've got 0 here, and then you have these 4 pins that correspond to the 0 ring. 1 here, that's your 1 GPIO ring. 2, etc. And you've got 4 pins that correspond to that. And then you have a bunch of them corresponding to 3 volts and ground. And they'll tell you what those other columns are, for example, the MCU pins and what it is on the schematic and stuff like that. And then these brackets indicate use with caution, which is very interesting. But they've got more notes on that all below. So if you get overwhelmed by this chart, just scroll down. They've got notes for all of these that tell you more about it. Uncoupling the default functionality. If you want to reuse those pins that are already used for like the LEDs and buttons on the board, you can change it. So you can break out those LED pins to something else, but they also tell you when they're connected to external or internal, pulled up or pulled down resistors, which is really helpful. There's some really interesting stuff going on with these LED pins, by the way. Okay, so first off, it's shown as a 5x5 LED matrix, right? But actually the way that they're connected is in a 3x9 LED matrix, which is very interesting and strange. So that actually means that there's 2 extra pins. There's like 27 options in this array, I guess. But they're using 25 of them to create this 5x5 LED grid. So if you're trying to program your own weird way of connecting to these LEDs, you might end up with what you think is going to be like a heart shape, but it ends up looking like some kind of Lovecraftian, like Cthulhu monster thing, or just like static or something, which could look really cool too. But if you're trying to create your own animations and it's not in one of the standard interfaces or one of the standard functions that they provide you, through MakeCode or MicroPython or whatever, then you might get some weird patterns, and that's probably why. Another thing, so it turns out that there's a light sensor going on that is using the same LED matrix reversed biased to use the LEDs themselves as light sensors, which is a really cool thing that you can do with regular LEDs as well. So similar to speakers and microphones or piezo discs, which can be used as either one, or what's another good example? Motors and generators. Often these things, like when they're sensing or reacting to electricity coming in from one direction, like coming into it, you can use them to create voltage and current by stimulating them, activating them. So if you turn a motor by hand, you're going to generate electricity. If you compress and decompress a piezo disc, you're going to generate a signal. And similarly, with an LED, you use it to, output light usually. These things often work better in one direction than the other, but like they can also work as a light sensor. And so that's what they're using as an ambient light sensor on the microbit, which I think is super cool. Let's have a look at some of the comments so I don't lose you. As a bonus, the Adafruit Clue board is pin compatible with the original microbit. It's totally true. If you have the Adafruit Clue board, which has a little graphical screen in the middle instead, and can run some little AI models and stuff, you can do AI on the microbit, by the way, using Edge Impulse. So much good stuff. But also you can do it on the Adafruit Clue, which is pin compatible. Why will people use microbit in the world of Arduino and Raspberry Pi? So it has, as I mentioned, it's really beginner friendly. So especially this one is designed to work with alligator clips. You can clip them on here. And this is the V2, so you've actually got these little detents that make it easier for the clips to not slip around and accidentally short to other pins. It's really beginner friendly, and it gives you space to upgrade. So you've already got an LED matrix built in. You've already got buttons built in. On this version, you also have sound and a microphone or sound sensor built in. You've also got, there's an accelerometer. You've got Bluetooth. You've got all these interface options already built into the microbit, and it's compatible with alligator clips, which are helpful for young fingers. So they're really good for people who are super new to electronics. Plus, there's space built in for people to graduate to a higher level as they learn more. So, for example, you see that there's these 5 large pins, but then there's 20 or 21 total pins on here that you can use for other things, and that's why there's these complicated pinout diagrams for something that seems to only have 5 large pins, but there's all these other pins that you can connect to once you're more comfortable with it. And as I showed a second ago with the Microsoft MakeCode programming interface, you also can graduate from, where is it? You can also graduate from drag and drop coding to writing code and typing it and understanding functions and things like that, from a very basic level to the written level. And it kind of introduces you to that, but gives you room to grow. So that's why I think that people will still be using the microbit, despite the fact that there's already Arduino and Raspberry Pi. Thank you for the question, by the way. There's also a power base that lets you use it without it being plugged in and using alligator clips. Yep, there's all kinds of expansions for the microbit. It's super cool. I'm not going to go through all of this documentation with you. There's so much useful stuff in here. There's also more information on the device abstraction layer. That's why there's stuff like the DAL correspondence in here. That's referring to the device abstraction layer. More just incredible documentation on this. There's also the MicroPython microbit docs on readthedocs.io that I've got linked below. So if you are using it with MicroPython, with, for example, the Mu or Thonny programming interfaces, then you can figure out how to interface with those input and output pins over MicroPython, which could be useful if you're designing your own thing. Super cool. I showed you this pinout.xyz. This is also linked below in the description, microbit.pinout.xyz. And then I just want to show you some open source options and other options that are around here for you. So we've got this GitHub repo that I've linked below as well, which is Anthony Kirby's KiCad microbit connector library. So you have a component and a footprint and also a 3D model, which is super cool. So all this stuff you can use to start designing your own microbit expansion in KiCad, which is a free open source PCB design CAD tool. There's, oh yeah, if you find the MicroPython docs intimidating, there's a whole introduction section that gives you just a little bit of an intro, and that's at the top of the left sidebar here. And then if you go further down, you get to the more intense documents. There's some other connectors available. Here's one from Adafruit for $3.95. It's just a straight pin out. It looks like they have headers connected. Oh, they don't. No. Okay, so this is another version that you can just plug directly into your own PCB if you're designing it in KiCad, for example. There's also, here's an interesting thing. Parallax and Edge.io both have breakouts that look different, but the weird thing is that Parallax shows the Edge.io one on their site, and Edge.io shows the Parallax one on their site. It's very strange. Not sure what's going on with that. It's just some interesting corporate stuff. And then there's a very simple one here. If you don't want to deal with all those pins in their little staggered arrangement, because this is both the front and back sides of the connector. The connector is usually, let me show you this close up. It's got pins on both sides, so it sandwiches the board in there. When you put your board in, it's gripped by pins on both sides. And that's why you have so many pins on here, because it's pins from both sides. As far as I can tell. I think it's also for mechanical strain, but I believe that's what they're going for there. Then we have one from Kitronic that's available on Newark. And SparkFun's general KiCad libraries, which have a bunch of, pardon me, KiCad. I've learned that since it's developed in France, you should say KiCad, apparently. But yeah, so they have a bunch of, if you're working with this KiCad library for the microbit connector, you might find it really helpful to check out the SparkFun KiCad libraries on GitHub. I use them for designing my stuff. There's tons of useful pieces in there, even if, for example, I'm using a CR1225 surface mount connector that doesn't look exactly like the footprint. It's close enough that I can use it in my design, even though I'm getting it from a different source. You don't have to just be using SparkFun components in order to use this library, but it is really helpful. They've got all kinds of stuff like surface mount and through-hole components for different types. Very nice. Yeah, it does look like a cartridge slot, doesn't it? Oh yeah, Hugo says, Microbit also has touch support on some pins, which the Arduino and Raspberry Pi don't have out of the box. That's also true. Well, some Arduinos do, but I think the Raspberry Pi maybe doesn't. And then there's a couple of other curious things on here. Oh yeah, one thing that I noticed while reading through the documentation on here, this is actually really helpful for me to do. It looks like a lot of info, but I already learned multiple useful things, including the fact that you can only have 3 PWM pins going at the same time. So if you're trying to do audio and a couple of servos, which I've done before, and I ran into some weird like synchronicity problems, but you can do it, but you got to be careful. And if you try to go over 3 PWM pins, then it's going to cut off the previous one. Yeah. That's all I got to show you today. Check out those links below for all these different edge connectors that I talked about, as well as the documentation. There's a wealth of cool stuff out there, and if you design your own, I would love to see it. I might do the same thing eventually. Thanks, SparkFun, and hack on. Yeah, have a great weekend.